A steel column swings through open air nearly 1,000 feet above Manhattan. One ironworker reaches out, steadies its movement, and guides it into place without a harness or a safety net. That single moment proves the title wasn't an exaggeration. The Empire State Building really was built floor by floor before tower cranes existed. Somehow, thousands of tons of steel kept climbing higher every week using methods almost forgotten today. Before we begin, tell me where you're watching from, because I'd love to know how far this story has traveled. The answer is even more astonishing than most people imagine. The answer begins years before the first steel column ever rose above Fifth Avenue. Long before workers balanced high over Manhattan, engineers faced a problem that seemed impossible to solve. Cities kept growing, land kept becoming more expensive, and businesses wanted more office space than the streets below could ever provide. During the late 1920s, New York was racing upward. Banks, insurance companies, and large corporations competed for prestigious addresses in the heart of Manhattan. Building outward was no longer practical because every available block had already been claimed. If developers wanted more space, they had only one direction left to go. Traditional construction methods had already reached their limit. Older buildings relied on thick masonry walls to support their weight. As structures became taller, those walls had to become even wider at ground level. After enough floors were added, the lowest walls consumed valuable interior space. A taller building actually became less profitable because so much of the ground floor disappeared behind solid brick and stone. Steel changed everything. Instead of depending on heavy walls, engineers designed buildings around a rigid steel skeleton. Columns carried the weight downward, while horizontal beams spread the loads across the entire frame. Exterior walls no longer supported the building, they simply enclosed it. That breakthrough allowed architects to dream much higher than ever before. Even with steel, another obstacle remained. Thousands of massive beams had to reach heights that no ordinary lifting equipment could manage. Modern tower cranes had not yet been invented. Mobile cranes lacked the reach needed for projects of this scale. Every piece of structural steel still had to arrive exactly where it belonged, often hundreds of feet above crowded city streets. Planning became just as important as construction. Factories fabricated every beam before it reached Manhattan. Each piece was measured, drilled, marked, and assigned a precise location inside the future building. Numbers stamped into the steel matched detailed engineering drawings, allowing workers to recognize every column and girder the moment it arrived. Delivering the wrong beam at the wrong time could delay hundreds of workers waiting above. Transportation demanded equal precision. Railroad cars carried the steel into New York, where trucks delivered it directly to the construction site. There was almost no room for storage. Streets remained busy with traffic, pedestrians, and neighboring businesses. Materials couldn't simply pile up beside the project. They had to arrive almost exactly when crews were ready to install them. Everything depended on timing. Surveyors established reference points across the foundation with remarkable accuracy. Engineers verified every measurement before the first column stood upright. Foremen coordinated deliveries, lifting schedules, and work crews, like conductors leading an enormous orchestra. One mistake at ground level could echo through dozens of unfinished floors above. By the time excavation crews completed the foundations, the real challenge was finally waiting overhead. Plans looked perfect on paper. Steel sat ready beside the site. Skilled workers understood their assignments. Now came the difficult part. Thousands of tons of steel had to climb into the New York skyline without the towering cranes every modern construction site depends on. Thousands of tons of steel stood ready beside the site. The only question left was how to lift every piece hundreds of feet into the air without the machines we now consider essential. That challenge became one of the greatest demonstrations of coordination in construction history. If you're enjoying this journey into forgotten engineering, Subscribe now because the most dangerous part of the story is still ahead. Engineers relied on climbing derricks instead of tower cranes. Each derrick sat directly on the steel frame itself, using the completed structure as its foundation. As another group finished a new level, crews dismantled the derrick, raised it higher, and secured it on the freshly completed floor. Step by step, the lifting equipment climbed alongside the building it was helping create. Unlike modern cranes operated from enclosed cabins high above the ground, these derricks depended on teamwork. Steam power handled the earliest lifts, while electric motors powered many of the machines used on the Empire State Building. Operators controlled heavy cables and drums from nearby platforms, carefully raising each load while watching the signals coming from workers positioned throughout the frame. Communication demanded complete concentration. Voices disappeared in the wind long before reaching the crane. Instead, trained signalmen used a language of hand motions that every operator understood instantly. A raised arm meant stop. A sweeping motion changed direction. Small gestures controlled enormous loads suspended far above the streets below. Accuracy mattered more than speed. Every steel column arrived with only a few inches of clearance. Workers standing on narrow beams guided each swinging member into place using taglines and steady pressure from their hands. They never tried to overpower the weight. They simply controlled its movement until gravity, momentum, and careful timing worked together in their favor. Strong winds made every lift more dangerous. A beam weighing several tons could begin rotating without warning. Even a gentle swing became hazardous when workers stood hundreds of feet above Manhattan with almost nothing protecting them from a fall. Experience taught them how to anticipate movement before it became impossible to control. Once the load reached its destination, another team moved into position immediately. Long steel drift pins helped align the connection holes, while heavy spud wrenches pulled stubborn members into perfect position. Temporary bolts secured the pieces just firmly enough to prevent shifting before permanent fasteners could replace them. No wasted motion, no second chances. Meanwhile, another derrick was already lifting the next beam. Below, trucks unloaded fresh deliveries exactly where they were needed. Above, ironworkers prepared the following connection before the previous one had even been completed. Every crew depended on the rhythm established by everyone else. Interrupt that rhythm for even a few minutes, and delays spread through the project like falling dominoes. Watching the operation from the street must have looked almost effortless. In reality, every successful lift represented years of experience, disciplined planning, and absolute trust between workers who often communicated without speaking a single word. Getting the steel into position was an extraordinary achievement. Keeping it there forever required something even more demanding, and the next 20 seconds would decide whether every connection lasted for generations. Keeping the steel in position was only the beginning. A beam balanced perfectly between two columns still wasn't part of the building. Until it became permanently connected, the entire frame remained incomplete. That responsibility belonged to the riveting gangs, whose timing determined whether the Empire State Building would stand for decades or develop dangerous weaknesses hidden deep inside its skeleton. 4 workers formed each riveting crew, and every person had a single responsibility. One heated steel rivets inside a portable forge until they glowed bright orange. Another caught them after they were tossed through open air. A third held each rivet firmly inside the connection, while the fourth drove it tight using a pneumatic hammer. Nobody hesitated because every second mattered. Hot metal cools quickly. Once a rivet left the forge, the crew had roughly 20 seconds to complete the entire process. If it cooled too early, it expanded incorrectly and failed to create the tight grip engineers expected. That single connection had to be removed and replaced before work could continue. Across a building containing millions of pounds of steel, even small delays quickly became expensive. Bright orange metal became the crew's clock. There were no countdown timers or warning lights. Color told experienced workers everything they needed to know. As the glow faded, the opportunity disappeared. Skill came from recognizing exactly how much time remained without anyone saying a word. Hesitation had no place in this sequence. The heater flipped a glowing rivet through the air with practiced accuracy. The catcher trapped it inside a steel can before passing it to the bucker-up, who pushed it into the waiting hole. Almost instantly, the driver pressed a pneumatic hammer against the opposite end, flattening the hot steel into its final shape. As the rivet cooled, it shrank slightly, pulling both steel plates together with tremendous force. That shrinking action made riveting so dependable. Instead of simply filling a hole, each cooled rivet clamped the surrounding steel tightly together. Thousands of those connections transformed separate beams into one rigid structural frame capable of resisting wind, weight, and constant vibration for generations. Construction echoed with a sound unlike anything heard today. Pneumatic hammers struck steel in rapid bursts from every direction. The sharp rhythm rolled across Manhattan from sunrise until late afternoon. People walking nearby often stopped, looked toward the growing tower, and watched another section of the skyline take shape above them. Photographer Lewis Hine captured many of these moments while documenting skyscraper construction during the early 20th century. His images showed workers sitting on narrow beams, guiding connections into place hundreds of feet above the city. Those photographs later became symbols of American industry, but they also preserved a craft that disappeared only a few decades later. By the time one riveting gang finished a connection, another beam was already arriving overhead. The building never waited. Steel kept rising. Crews kept moving. Every completed joint allowed the next floor to begin without losing momentum. Soon, the skeleton stood strong enough to support itself, yet a steel frame alone couldn't become the world's tallest office building. Another army of skilled trades was already preparing to transform exposed steel into the finished landmark people still recognize today. Another army of skilled trades was already waiting below the steel frame. The moment the riveters finished one section, new crews moved in without hesitation. Their job was completely different, but just as important. They would transform an exposed framework of steel into a building where thousands of people could safely work every day. First came the fireproofing crews. Structural steel was incredibly strong, but intense heat could weaken it much faster than most people realized. Engineers had learned that lesson from devastating city fires decades earlier. To protect the frame, workers wrapped beams and columns with specially shaped terracotta blocks and layers of concrete. Every section had to fit precisely because even small gaps reduced the protection the steel depended on. Behind them came another wave of specialists. Electricians pulled miles of wiring through the growing structure, while plumbers installed water lines, drainage pipes, and heating systems. Elevator mechanics assembled shafts that stretched from the basement to the upper floors. Carpenters built temporary platforms before finishing walls, ceilings, and office interiors. Window crews followed close behind, sealing the building from wind and rain, one level after another. Nothing happened by accident. Each trade worked according to a carefully planned schedule. If electricians arrived too early, they found unfinished walls. If plaster crews appeared too soon, other workers damaged completed surfaces. Every team moved through the structure in a precise order, allowing dozens of different jobs to happen at the same time without slowing the overall project. Temporary elevators became the lifeline of the site. As additional floors rose, Construction hoists climbed higher alongside the building, carrying workers, tools, and materials throughout the day. Without those constantly moving lifts, crews would have spent hours simply walking up unfinished stairways instead of building. Outside the structure, deliveries continued almost non-stop. Stone for the exterior, glass for the windows, pipes, cables, doors, flooring, and countless smaller supplies reached the site exactly when needed. Storage space remained extremely limited, so timing mattered just as much as it had during the steel erection phase. Materials arrived, moved upward, and disappeared into the building almost immediately. More than 3,000 workers filled the project during its busiest period. Looking across the site, it resembled a perfectly organized chain of activity rather than a collection of separate jobs. One crew finished its task, another stepped forward, and progress never stopped. That steady rhythm allowed the Empire State Building to rise at a pace that amazed engineers around the world. Visitors often remember the height because it dominates the skyline. Builders remembered something different. They remembered the organization required to keep thousands of people working together without confusion. The greatest achievement wasn't simply constructing a record-breaking tower, it was maintaining a system where every worker understood exactly what had to happen next. By the spring of 1931, the transformation was almost complete. Steel had disappeared behind finished walls. Empty floors had become offices. Construction equipment slowly vanished as permanent elevators, polished stone, and shining windows took their place. The skyscraper was nearly ready to open. Its fame would spread across the world, but the people responsible for creating it were about to fade quietly into history, leaving behind one of America's greatest engineering achievements and almost none of their own names. Opening day finally arrived in May 1931. Newspapers celebrated the completed Empire State Building as the tallest structure on Earth. Crowds admired its height, its speed of construction, and its striking appearance. Yet most headlines focused on the finished landmark instead of the thousands of workers whose skill had made the achievement possible. More than 3,000 people helped build the tower during its busiest months. Riveters, crane operators, surveyors, carpenters, electricians, masons, plumbers, steam fitters, truck drivers, and laborers all played essential roles. Many worked long shifts 6 days each week, knowing the project stayed on schedule only if every crew finished its assignment on time. Danger remained part of everyday life. Protective equipment looked nothing like today's standards. Hard hats were uncommon, and safety harnesses were almost non-existent. Guardrails covered only limited areas, while temporary wooden walkways offered little protection against strong winds or simple mistakes. Workers depended far more on experience, balance, and trust than on safety equipment. Construction companies understood the risks, but building practices reflected the standards of the early 20th century rather than those of today. Every climb onto the steel demanded complete concentration. A single careless step, loose tool, or unexpected movement could cause serious injury. Even so, crews returned every morning because the work provided steady wages during one of the hardest economic periods in American history. Many families relied on those paychecks to survive the Great Depression. Jobs were scarce across the United States, making employment on the Empire State Building especially valuable despite the danger. Men accepted difficult conditions because supporting their families mattered more than avoiding risk. Their names rarely appeared in history books. Architects, company owners, and famous photographs became part of the public story. Countless skilled tradesmen disappeared into payroll records, newspaper archives, and faded construction reports. They left behind almost no personal accounts describing what those months felt like from the steel itself. Still, their craftsmanship remained visible long after they were gone. Decade after decade, the building continued resisting powerful winds, harsh winters, summer heat, and millions of visitors. The connections they tightened, the columns they aligned, and the floors they assembled continued performing exactly as intended without attracting attention. That quiet success says everything. Good engineering often becomes invisible because failure never arrives. People notice collapsing bridges or damaged buildings. They rarely think about structures that continue standing year after year without demanding attention. The Empire State Building belongs to that second group. Its greatest compliment is simply that it still works. Generations of engineers later improved construction equipment, introduced stronger materials, developed safer workplaces, and replaced many traditional methods with modern technology. Even so, the discipline shown by those early crews remains impossible to automate completely. Machines can lift steel faster than ever before, but judgment, planning, and teamwork still determine whether complex projects succeed. The building itself became a global symbol. Its deeper legacy, however, reaches beyond architecture. It reminds us that every famous landmark rests on the dedication of ordinary workers whose names may disappear, while the quality of their work continues speaking for them long after they are gone. One final question still remains. How much of what those builders accomplished nearly a century ago would still look familiar to an ironworker standing on a skyscraper today? The next time you look up at the Empire State Building, remember the thousands of forgotten workers who raised it floor by floor without tower cranes. If you enjoyed this story, subscribe for more forgotten engineering and historical construction documentaries, then watch the next video to discover another incredible achievement hidden in plain sight.